So here we'll see some problems based on molality, another concentration of solution, molality and mole fractions. So we'll see this problem. This problem is mole fraction, based on mole fraction. 5.85 gram of sodium chloride dissolved in 90 gram of water. What is the mole fraction of sodium chloride? So this question is very easy. We have given one solute is there, one solvent is there. The solute is NaCl and solvent is water. So mole fraction will be definitely, so write down here, mole fraction is equal to, so mole fraction moles of solute is NaCl. So this is weight they have given. So we know that moles of solute divided by total moles of solute and solvent. So here definitely you can write here 5.85 gram and molar mass of NaCl is 23 plus 35.5. So this will give you 58.5. So right, divide it here, 58.5, and 7 total moles means moles of solute plus moles of solvent. So 5.85 divided by 58.5 and plus here moles of, again, water is there. So water they have given weight 90 and molar mass of water is 18. So if you solve it, this problem, so you will get the answer 0.0196. So this is the mole fraction of NaCl of solute. So here it was solute, and mole fraction of solute plus solvent is always equal to 1. So mole fraction of water will be 1 minus 0.0196. Now second question. So second question is there, 2 moles of ethyl alcohols are present with 6 moles of water. 2 moles of ethyl alcohols are present in 6 moles of water. What is the mole fraction of alcohol? So again same questions. So which is way to solve it? Mole fraction of ethyl alcohol we have to find out. So again moles of alcohol divided by total moles. The total moles means alcohol plus moles of water, total moles. So again, how much moles is given alcohol? Very simple, it is given 2 moles they have given, and down is 2 plus 6. So this becomes 2 by 8. So on solvent 2 by 8 is nothing, 0.25. So it is this is the mole fraction. Again you can see in mole fraction there is no unit. In mole fraction there is, because this is a very pure ratio. So here we do not require any unit. Okay. So now we see next question, that is third is there, an aqueous solution of urea, which contain 18 gram of urea in 500 centimeter of solution has a density of 1.052 gram per centimeter. So if the molecular mass of urea is 60, what is its molality? So on molality we know that, so weight they have given, density I have given. So we have to find out molality, and we know molality very well. So molality is written by small m. This is nothing but the moles of solute divided by weight of solvent. Weight of solvent in kilogram. This would be in kilogram. Okay, this is the main formula of the solvent. So how to find out? So mole solute is urea and solvent is water. Nothing, aqueous solution is water is there. So urea given, this one volume is also given. Okay, so first we have to find density is also given. So weight of solvent we can find out. Weight of solvent is nothing but the mass of the solute, mass of the solution minus mass of solution minus mass of solute, So mass of solution is how much? So volume and density, so volume they have given 1500 and density they have given 1.052. This is the mass of the solution. Minus solute is they already have given 18 grams. So if you solve it, you will get answer. This is the weight of the solvent. So this we can put this value directly over here. So if you put this one this side, so you will get this value. Weight of the solid is already we know that 18 upon 60. This is the weight of solid, and weight of the solvent we know that 1500 multiplied by 1.052. This is the mass of the solution, and subtract with the help of 18 grams. Okay, and again this is the in gram. This is in gram. So this is gram. So again you have divide by multiplied by 1000. So this will come under kilogram. So on solving you will get answer 0.192. I am not solving all this problem. This you can use by yourself. You will get this much result. So this is your molality, and this is the unit we have. The small m is the unit. So you can write here unit also. So next we'll see problem. So next problem is if in the aqueous solution of sulfuric acid a mole fraction of water is 0.85, and what is the molality of solution? So in the aqueous solution sulfuric mole fraction they have given, we have to find the molality. This is the relation between molality and mole fraction. Okay, so we know the mole fractions. If you write the mole fraction of what? Sulfuric acid H2SO4 and divide by mole fraction of water. Okay, so how much will be there? So mole fraction of water, because denominator is same only. So mole fraction of acetic acid, sulfuric acid, but acid will be, you can see here mole fraction of water is 85. So here we can write 0.85 and mole fraction of water. So total mole fraction of water and acid is 1. So 1 minus 0.85 you will get here 0.15. So this is the ratio. So again we can see here what is molality. We can find molality is nothing but the mole fraction of moles of H2SO4. You can see right here, and divide by weight of water. So multiplied by 1000. Suppose this is in gram. So this we can write moles of weight fraction. We know already that is how much? 0.15. This is your 0.15 is the, and what is the weight of water? So weight of water we can write here moles of water multiplied by 8. So this is nothing but the moles of water multiplied by 18 into 1000. So this is the moles of water multiplied by 18 into 1000. So you will get here how much? So on solving, so you will get here multiply divided 0.15 and moles of water is how much? 0.85. Okay, and again 1000 by 18. So this is the moles of water. So on solving you will get 9.8 molality. So this is the molality of the solutions. Now next is similar type of questions based on molality. So this is here, what is the molality of the solutions, okay, of the 15% mass by volume solution of H2SO4, and whose density of is 1.1 gram per centimeter cube. So what is the molality of the 50% volume? So 15%, this is mass volume, relation between mass volume and density, and you have to find the molality. So mass volume means 15% means 15 gram is the solute and 100 ml is the solution. So this is the volume, this is the weight. So how to find out? So molality we know it is very clear. So molality is moles of solute and divide by here weight of solvent in kilogram. So this is the formula we know very well. Moles of solute divided by weight of solvent. So again we can see solute they have 15 gram they have given here. So we can write here 15 gram. This is nothing but the H2SO4. So 15 by 98. So we will get here moles of solute. 50 by, so weight by molar mass. Again how to find the weight of the solvent? So for weight of the solvent we can see here the weight of solvent is mass of the solution minus weight of the solvent. So mass of the solution is, so they have given 100. So this is the 100 is the volume and density is 1.1 gram. So this is your mass of the solution. This is the mass of solution, and minus what is the weight of the solvent? So solute is again 15 gram. So this is the mass of solution, this is the weight of the solute. Okay, and again you multiplied by this into 1000. Okay, so we'll get here weight of the solvent. So on solving this one, so we'll get a result. So this is your 1.6 molality. So this is the way to find the molality of the solutions. Next we'll see density of 2.05 molarity of solution of acetic acid in water is 1.2 gram per ml. What is the molarity of the same solution? So it is similar like a previous question. Density they have given, acetic acid and water is given, 2 is given, and we have to find the molarity of same solution. So right here same thing, molality is equal to moles of acetic acid, and again divide by weight of or mass of solvent in kilogram. So again you can solve it. So moles of solute means moles of solute they have given. So density 2.05. So 2.05 m means 2.05 moles. This is the meaning of 2.05 moles per liter. So right here moles 2.05, and mass of the solvent is again same, mass of the solution minus mass of the solvent. The mass of the solution is volume is per liter they have given. So here volume is 1000 ml. So you can write here 1000 ml multiplied by density is 1.02. This is the mass of the solvent, and minus 2.05. This is the moles of the, this is the solution means water, okay, and this is the weight of the, this is the solution, not water, this is the solution, and here this is the acetic acid, okay, this is the acetic acid. So acetic 2.5, and molar mass of acetic acid, so you can see here CH3COOH. So this is come nothing but the 60 if you calculate it. This is 60. So you solve it, again you multiply it by here 1000. So you have to write in kilograms. So on solving you will get here 2.05 multiplied by 1000 and divide it. This will be your 1020, and minus this is your 123. So you multiply, you will get 123. So again you will get here 2.05 into 1000, and again if you divide it you will get here 897. So on solving you will get here 2.285. So this is the molarity of the solutions. So these are the problem. Based on all these are not too much difficult, it is easy. So we will see problems like some more different problems. Calculate molality of 1 liter of solutions of 93% H2SO4 by volume. The density of solution is 1.84 gram per ml. So again molality they are asked, so again we will apply the same formula. The same formula means again here molality is equal to moles of H2SO4, okay, and divide by mass of water in kilogram, okay. So again here we write here 93% means it is very clear. 93% means 93 gram H2SO4 and 100 ml, nothing given, so we will take here 100 gram of water, 100 gram of solution. So 93 gram H2SO4 and 100 gram of solution. So again moles of solute, say 93 divided by 98, and again divided by density they have given. So mass of the solution minus mass of the solute. So mass of the solution is 1/84, density into volume 1000, and again subtract it by 93 grams. So this is the solute, and again you multiply this into 1000. So on solving this answer you will get 93 by this one 1000 divided by, this is solving 184 minus 93. So or you will get here 10.42. I am not solving these things, so already I have calculated. So if you solve you will get this result. So my basic idea is how to approach the problem, how to solve the problem. So that is my basic approach. So I am not discussing how this is the mathematical parts. So mathematical parts, just do it by yourself. So now next is a compound. So a compound with H2X with molar weight is just molar weight is 80 gram is dissolved in a solvent having density of 0.4 gram per ml. Assuming no change in volume upon dissolution, what is the molarity of a 3.2 molar solution? So this is the compound molar mass they have given, okay, and after dissolving the density become this much. and again there is no change of volume upon dissolution. So if you dissolve it, there is no change of volume even after mixing this compound also. And they have given what is the molarity of the solution. This is 3.2 moles. So we know the moles of solid also. This is 3.2 moles. So we can write here. So again we have one more information, that is volume of solution. Volume of solution is almost equal to volume of solvent. So this we know, volume of solvent, this is equal to, is very equal. So this volume solution, how much? 1 liter. Solution is 1 liter. So we can write equal to 1 liter of solution and 1 liter of solvent. Okay, this is the one basic information which we need to understand. Okay, and in 1 liter how much moles is present? So in 1 liter, so there are 3.2 moles of solute is present. So this is 3.2 moles of solute is present in 1 liter of solvent. Okay, so now our work become more easy. So moles of solute is nothing but the weight, moles of solute, molality, moles of solute divided by weight of solution. The moles of solute is this much, 3.2, right here 3.2, and again here weight of the solution. The density is given. So weight of solution is 100 multiplied by 0.4. So this is your density. 100 multiplied, this is the volume. Volume of solution is this much, 100 into 0.4. So this is the solvent they have given. So 1 liter already we know that. Okay, so this becomes how much? 1000. So that's 100 into 0.4. So total volume is 1000. I think this will be 1000. 1 liter into density solutions, and again we have total volume. This is equal mass of solvent. 1 liter solvent, volume is given, density is given here. So this is density, this is the volume, and again you multiply it by 1000. So you just cancel it, this one. So this becomes 33.2 divided by 0.4. So you will get answer 8. So this is 8 is the molarity of solutions. Now see next question. Calculate the molality of iodine in benzene solution in which moles fraction of iodine is 0.2. So this is the question given. So molality of I2 is given. What is the mole fraction of iodine? That is 0.2. So again same. So we can write here mole fraction of iodine by mole fraction of C6H6. So this is nothing, 0.2 and divide by 0.8. Okay, we have to find the molality. So first we'll take this ratio of these two. So this is 0.2 by 0.8, and again we can write this ratio if you break this one. So molality of I2 they are asking, what is the molality of this solution. So again moles of I2 and divide by here weight of solvent into 1000. So this we require to find out. Okay, so how to find out? So we can write it, this we can modify. So on modifying we can write here. So this is your Ni2 divided by weight of the C6H6 multiplied by molar mass of 78. So this will become 1 by 4. So here we are getting this result. Okay, so n by 2 into 78 is nothing, 1 by 4. So this we can put directly here value. So if you multiply, keep this side, Ni2 by weight C6H6 equal to 1 by 4 into 78. So we will put this value directly over here. So here we can write here 1 by 4 into 1 by 78 into 1000. So on solving you will get here 3.205 molarity. This is the result. So we will see one more problem. So one more problem is ammonium sulfate here of 1 molar concentration. So this is 1 molar concentration, okay, is present in 1 liter of 2.684 gram per cc. So how many moles of barium sulfate would be precipitated on adding barium chloride in excess? Means if you add barium chloride in ammonium sulfate, so they will form barium sulfate. Okay, so how much barium sulfide is added to convert it, so that it will convert into So how much chloride is added? So aluminum sulfate will be, all sulfate will be added to the barium, and it will be precipitate. So this we need to find out. Okay, and we have this is solution of aluminum sulfate is given 1 molar concentration, means 1 mole in 1 liter, whose density also given. Okay, so to find the molarity, first we have to find how much, what is the weight of this, how much moles of aluminum sulfate is there. This we need to find out. What is the moles of aluminum sulfate? So let's take moles of aluminum sulfate, Al2SO4 whole thrice is suppose x mole. This is the x mole. Okay, so and we know the formula, that is molality is equal to moles of solute divided by weight of solvent. So this is the formula we know very well, and into 1000 if this is in gram. Then so again here we see here, so weight is x gram, but the weight of the solvent is how much? So total weight is given 1000, total weight 1000, and density of solution is 2.684. Okay, and the again weight of the solute. So weight of solute will be, this is the moles, right here, moles into molar mass. So molar mass of Al2SO4 is Al2SO4 if you solve it, so this becomes 54 and plus 3 into 96. So you will getting here 342 gram. Okay, so this will be your 342 gram weight of the solid, and into 1000. Okay, and this is equal to 1. So this is the 1 means 1 molar. Already this is given in the question. Okay, so on solving we will get here x equal to 2. This value we will get. So 2 is the moles of aluminum sulfate. So now, so in aluminum sulfate SO4, okay, so this is converting into which one? Moles of sulfate. So this is actually 2 mole. Aluminum sulfate is actually 2 mole. So this we get from this one, and we are getting how many sulfates? So 2 into sulfate will be your 6 moles of sulfate ions. Okay, so answer will be your 6 moles of barium sulfate will be